वेलकम यू ऑल। कंटिन्यूइंग विद द मैग्नेटिज्म। आज का जो लेक्चर होगा दैट इज फोर्स ऑन ए कंडक्टर इन ए यूनिफॉर्म मैग्नेटिक फील्ड, और उसके बाद द फोर्स बिटवीन टू कंडक्टर्स कैरिंग करंट इन ए सेम डायरेक्शन। तो अगर एक मैग्नेटिक फील्ड में सपोज मैग्नेटिक फील्ड यूनिफॉर्म मैग्नेटिक फील्ड, और इसमें हम एक कंडक्टर को इंसर्ट करते हैं। Suppose insert a conductor of length L and area of cross section E. Calculate the force on this conductor when placed in a uniform magnetic field. Force on a conductor placed in a uniform मैग्नेटिक फील्ड। लास्ट क्वेश्चन जो हमने किया था दैट वाज फोर्स ऑन ए चार्ज पार्टिकल व्हेन प्लेस्ड इन ए मैग्नेटिक फील्ड। आज का जो होगा दैट इज फोर्स ऑन ए कंडक्टर प्लेस्ड इन ए यूनिफॉर्म मैग्नेटिक फील्ड। एज यू नो, जो कंडक्टर होता है उसमें बहुत सारे चार्ज कैरियर्स होते हैं। वहां पे हमने सिर्फ एक चार्ज पार्टिकल को डाला था ऑफ चार्ज क्यू, हमने कुछ चार्ज पार्टिकल्स की बात की थी, और यहाँ पे हम कंडक्टर की बात करेंगे। और चूंकि कंडक्टर में जो चार्ज पार्टिकल्स होंगे वो बहुत ज़्यादा होते हैं, then n number of charged particles, and E is, if we consider the electron, then E is the charge of each electron. Then you have Q is equal to Ne formula. Instead of Q, you can write Ne, and those particles are moving on this conductor. हम स्टेडी स्टेट करंट की बात कर रहे हैं। द चार्ज पार्टिकल्स मूविंग ऑन दिस कंडक्टर फ्रॉम वन डायरेक्शन टू अनदर डायरेक्शन बिकॉज वी आर सेइंग दैट करंट कैरिंग कंडक्टर। सो द करंट definitely when we talk about the conductor, then there is a drift velocity v of each average velocity of the electrons will be the drift velocity, and your total charge is equal to Ne number of charged particles and charge of each particle, and containing in the volume of this conductor be L into A. L is the length, A is the area of cross section. So you have a conductor of length L and area of cross section A placed in a magnetic field, and the current is carrying in the this conductor. So the total charge Q will be equal to N number of charged particles in the conductor into charge of each particle, if we consider the electron, into area of cross section, into L. This is volume. The volume containing the number of charged particle and charge of each particle. So the total number of charge. इससे पहले जो क्वेश्चन था that was for a particular charge Q. That can be E electron, that can be another charge. But here we are talking about the conductor. So conductor is containing the number of particles N in a volume Al, and each charge has a charge magnitude of charge E. So this is the Q, and you have the velocity, drift velocity instead of this normal velocity. You know that we are considering the average velocity of each charged particle. So we know the force experienced by a charged particle is Q into V cross B. ये आपने पिछले लेक्चर में किया था। F is equal to Q into V cross B. Now we substitute instead of Q this value and V instead of drift velocity. So you get F is equal to N E A L into V cross B. यहाँ पे हम थोड़ा अरेंज करेंगे। F is equal to N E A V D into L cross B, because यहाँ पे हम L insert कंडक्टर इंसर्ट कर रहे हैं मैग्नेटिक फील्ड में। So direction of current, the direction of this conductor with respect to magnetic field will decide the force. So जो ये पोर्शन है N E A V D, this is superscript D. This is known as you know, relation between drift velocity and current, N E A V D. So instead of this I can write I. So F will be equal to I into L cross B, or you can write I into L B sine theta. So the force experienced by a conductor in a uniform magnetic field is ILB sine theta, or F in vector form is I into L cross B. So here you find out that the force depends upon the direction of the conductor. The way you calculated the force experienced by a charged particle, we consider the direction of velocity and magnetic field, but in case of conductor, you have to count the direction of the conductor with respect to magnetic field. So if that conductor is parallel to magnetic field, then theta is 0, you have a 0 force. And if you have a theta at right angles, यानी कि magnetic field के साथ अगर आपका conductor 90 डिग्री पे बैठ जाता है ऐसे, you have a direction of magnetic field, direction of conductor, conductor, then theta is 90, you have a maximum force experienced by this ILB, sine 90 is 1, ILB is the maximum force when a conductor experiences in a uniform magnetic field. This is the formula for the force experienced by a conductor in a uniform magnetic field. You simply can write, put down this F is equal to Q into V cross B, but instead of Q, you have a total charge NE into AL, this volume, the conductor of volume AL, containing n number of charged particle, and E charged particle has charge E. You get total Q, and instead of V, you have a VD. You can rearrange them, and you get the solution. But you can also write in other words, like if you have same conductor, and you know F is equal to, if it is a magnetic field, can you write otherwise, if magnetic field and this conductor making angle theta in direction of B, and this LL, and this is area of cross section A, and you know the force experienced by the charge is F into Q into VB, or you can write F is equal to QVB sine theta. Since F is equal to, you can also write it like way, F into, this V is a velocity, drifting velocity. A charged particle can move from one end to another and traveling a distance L, and taking time T to move from this end to this end. So you can write instead of L by T into B sine theta. So you can rearrange again, F is equal to, you can write L into Q by T like this into B sine theta. And you know charge per unit time, the total charge containing in the conductor, that gives current I, this is L, this is B, this is sine theta. So you can write F is equal to I into L cross B. This is another way to calculate the force experienced by a conductor placed in a uniform magnetic field. और इसके फिर एंगल्स है 0 डिग्री पैरेलल होगा, जैसे चार्ज पार्टिकल का है कोई फोर्स नहीं एक्सपीरियंस करेगा, 90 डिग्री पे होगा, मैक्सिमम होगा, एंटी पैरेलल होगा तो 0 तब भी होगा. This is the way, another way to express it, that how you can calculate the force experienced by a charged conductor placed in a uniform magnetic field. You just convert this velocity part. आप इस velocity को convert कर सकते हो, because velocity will be the distance by time. Distance, a charged particle can calculate the total distance on the length of the conductor. एक charged particle एक end से दूसरे end तक की जाएगा, तो उसकी जो total distance होगी, that will be the length of the conductor, and it will take time t. So instead of v, you can write L by t, distance by time, and you rearrange this. L यहाँ ले जाओ, Q यहाँ ले जाओ, Q by t becomes charge per unit time, that becomes current I. L यहाँ ही रहेगा, B यहाँ रहेगा, sin theta is equal to F into I into L cross B sin theta. This is the force experienced by a charged particle when placed in a uniform magnetic field, and F is equal to Q into V cross B is the force experienced by a charged particle when placed in a uniform magnetic field, and this is the force experienced by a conductor placed in a uniform magnetic field. These are the two equations, and with respect to special cases, you can calculate the maximum force, minimum force depending upon the angle theta. So this was the force on a charged conductor placed in a uniform magnetic field. Thank you very much.